All right. So, we discuss real valued function of a real variable, that is functions from R to R or from some subset of R into R, and these functions symbolically are written as y equal to f x. Similarly, if I change the domain space by R 2 by some subset of R 2 into R, then its symbolic representation will be like this: f of x 1 x 2 is equal to some y. Here y is a real number, you can say it is a real variable, and x 1 x 2 are two independent variable. So, you have x 1 x 2 related to y through the function f. So, we will call such functions as real valued functions of two variable, two independent variable x 1 x 2. Okay. This is the second case, and thirdly, if you have functions from say C to R, you will call these functions as real valued function of a complex variable z, and I will denote this function as f of z equal to something y. All right. So, here z is an independent variable, it is a complex variable, and y is a real variable. Y is a dependent variable and z is a independent variable. And number 4, I can think of functions from say subset of R or the whole R into say R 2 or R 3. Okay. Now, these functions you must write down as f of t equal to a vector R. The elements of R 3 are actually vectors, or simply I can write down, in place of f t R, I will write down R equal to R of t, where t is varying between a and b. Okay. Now, these functions we will be concentrating on these type of functions, vector valued function of a real variable. Let me write down the name. So, these are vector valued functions of a real variable. So, first try to see them geometrically, how do they represent. So, if you consider an interval a b, suppose here is an interval a b, and you map this interval through certain function f. Okay. So, the image of this f will be a curve. Now, you can see if I choose a point t naught over here, its image will be a point on the curve, and this point, if I join it with the origin O, this will become a vector R which depends on the point t naught. Okay. So, geometrically what are you doing is, you are mapping the points of the interval into the space, and you can visualize as if you have taken a piece of a thread and you are deforming through some deformation f, and this deformed shape will be a curve. Okay. So, this is the curve which is written as R equal to R t, where t lies between a and b,
Okay. Now, this representation I will be